Imagine a tremendous gathering, played by a perpetual number of stars, planets, and moons all playing together superbly. At any rate, there is one explicit fragment of this ensemble that has shocked space specialists for a seriously significant time frame: exoplanets. Exoplanets are ordinary planets that exist outside our planetary system, hid away somewhere deep in the Milky Way. You might be surprised to find that among the gigantic number of galactic objects, there are exoplanets so like Earth, so tantalizingly similar yet confusing that they might be our planet's divine twin. We plunge into the charming space of Proxima B, found just 4.2 light-years away. The James Webb Space Telescope is transforming our journey for an understanding of these divine secrets. Imagine a second when your mind ventures across the huge vastness of our reality, the Milky Way, which is home to more than a quadrillion exoplanets. That is a number with 15 zeros. To place this number in context, if each of these exoplanets were the size of a grain of sand, we wouldn't simply fill the Grand Canyon, we would have enough to make another landmark on Earth, a Grand Canyon 2.0 that would extend for a huge distance. It is generally surprising that around 20% of these glorious bodies have been designated Earth-like in terms of geology and atmospheric structure. That means there is a 1 in 5 chance of seeing a twin of our planet. And the story doesn't end there. Close by these planets, there could be another quadrillion moons, rough satellites like our moon, trapped in a gravitational dance with their parent planets. If you somehow manage to ponder tracking down another body in space that harbors life, or could do so, the universe offers a flood of opportunities. Now that we have laid out the material of unimaginable scale, it's time to introduce the master craftsman prepared to paint its complex nuances, the James Webb Space Telescope. This heavenly Sherlock Holmes, with its amplified central focal point replaced by customizable lenses, beats even the most advanced optical instruments. We're not discussing any ordinary lens. Its 6.5-meter primary mirror is 2.7 times greater than Hubble's. Imagine the detail it can separate even in the smallest blaze of a star billions of light-years away and then analyze the nuances of orbiting planets. What makes the James Webb Telescope revolutionary isn't simply its seeing power, but also its highly advanced technology, including sensors and spectrographs. These tools can do considerably more than observe. They can analyze and channel the remarkable light signatures emitted or reflected by celestial objects to decipher their atmospheric conditions, harmony, density, and even mass. Acting as a space researcher, the telescope can determine whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the ability to answer these inquiries, lifting it from a simple observer to a scientific genius. It's not just an advance over its predecessor, Hubble, it's more like a quantum leap. Just as we extend our gaze across the complex landscape of the universe, it's worth focusing on one specific star in the divine show, Proxima B. Since its discovery in 2016, this baffling planet has stood out as a Shakespearean legend full of unpredictability and problems astonishing stargazers and anthropologists alike. What's the deal with all the fuss? First of all, Proxima B is basically in our galactic neighborhood, just 4.2 light-years from Earth. To put it in context, if you could beat the universal speed limit and travel at the speed of light, you would arrive in just over 4 years, about the same amount of time it takes for your favorite program to fall into reruns. But let's dive deeper into why this class is so critical. We're examining a universe that stretches over 93 billion light-years from one end to another. So finding a planet so close and so uplifting for scientific exploration is like finding a gem in a pile the size of Mount Everest. A gem that potentially holds mysteries about existence itself. In the grand tapestry of the universe, Proxima B is a complex thread, offering us significant hints that could redefine how we understand habitability and life beyond Earth. It's not just Proxima B's nearness to Earth that excites scientists, but also the captivating signs that this planet isn't just Earth-like, but potentially Earth 2.0. Proxima B sits comfortably in what space specialists call the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine waterfalls, meandering streams, vast lakes, and perhaps oceans as deep and mysterious as the Mariana Trench. For one, a single day on this entrancing exoplanet lasts a staggering 11 Earth days. Imagine first lights that not only introduce a new day but unfurl slowly, resisting giving way to afternoon. Sunsets linger, creating bright hours that photographers long for. While it sounds idyllic, it also has significant implications for its climate and habitability. How would human biorhythms adjust to the patterns of light and dark on Proxima B? Would we really need to eat 3 or 4 times as much in a single day? Would we sleep the same way? On this very strange world, the basic patterns of life, as far as we know them, would be simultaneously tantalizingly familiar and frustratingly peculiar. It's as though nature is giving us a riddle wrapped in a riddle, testing our understanding of what makes a planet livable. You may wonder how we can gather accurate and reliable data about a world we've never visited. The James Webb Space Telescope delivers all its capabilities like a giant Swiss Army knife. It's more than just a telescope, it's a complex research lab in the vacuum of space. Thanks to its innovative technology, cosmologists not only observe planets but examine them through a prism of scientific instruments that would make CSI labs look basic. Using advanced spectrographs, the Webb telescope can analyze the light emitted and reflected by these distant planets. Each element or compound in a planet's atmosphere absorbs or emits light at a specific frequency. By focusing on these patterns, scientists can perform a remote biopsy of celestial bodies, determining not only atmospheric pressure and density, but also the possible presence of compounds essential for life, like water, organic carbon molecules, and even oxygen. Space legal science is not just cosmology, it's space criminal science. We don't sit idly waiting for clues to come to us. We actively seek them, exploring the atoms and molecules that make up these complex worlds. The Webb telescope isn't just an eye in the sky, but a highly specialized research lab, investigator, and vast detective all in one. It allows us to turn our hypotheses and theories about alien worlds into methods to confirm or deny them, changing our understanding of what might exist beyond our blue dot. Just like in any science fiction thriller, scientists using the James Webb Space Telescope received something surprising from Proxima B, a signal so astounding that it spread throughout the academic halls and social media. Named as a potential tech signature, it was an electromagnetic discharge so complex and intricately designed that it could indicate the presence of an advanced civilization. The collective heartbeat of humanity seemed to stop at the peak of a discovery that promised to reshape our view of reality. Could the signal be the actual proof that we are not alone in the universe? And just as quickly as it appeared, the signal disappeared without repeating, leaving behind not just a stunning silence but also a maze of unanswered questions and bubbling hypotheses. The solitary mission cast a sad remnant of mystery over Proxima B, sparking wild discussion and speculation. Was it just a passing oddity, or is it part of a much bigger story, more perplexing than we can imagine? But wait, the tale of our cosmic exploration is far from over. The ink has not yet dried, and new chapters are still being written. This time, it's not just conventional specialists, but Harvard researchers who are leading a shift in perspective. As we continue the search for extraterrestrial life, they are not satisfied with just studying the signals and anomalies we've discussed so far. They're upping the ante by turning the James Webb Space Telescope into a kind of giant night vision telescope. They plan to search for artificial light sources in both the dark and illuminated areas of distant worlds. We're looking at staggering possibilities, such as the chance of detecting artificial versions of cities glowing in the dark like brilliant street lamp systems. Imagine seeing the glowing light emissions. It could be a city humming with the presence of an advanced human civilization, transmitting its glow into the vast oceans of space.